Hello and welcome to this video. My name is Carlos, but you can call me Cali. In this tutorial, we are going to build a web attack detection system using machine learning. So let's take a look at the overview of the project. It's going to be an AI-based approach to detect common web attacks using machine learning. Here I have chosen OWASP Juice Shop, which is a vulnerable website created by OWASP, and I wanted to join this website with the vulnerabilities, with one of the top 10 vulnerabilities. In this tutorial, we are going to cover broken access control, security misconfiguration, injection, authentication failures, and mishandling of exceptional conditions. So why are we actually going to build this project? So nowadays we have different products in the current market to detect some common attacks, such as web applications firewalls and next generations firewalls, as well as antiviruses, are with options to detect malicious activity in our network. However, these systems are based on signatures or predefined rules, making them vulnerable to evasions through payloads, obfuscation, encoding, and modern attack patterns. So with our machine learning model, what we want is to learn different patterns, recognize them, and detect them, so we can stop them before hurting our systems. How this model will work? So first of all, we have to gather data. We are going to create malicious prompts. We are going to attack OWASP Juice Shop with SQL injections, cross-site scripting attacks. Specifically, we are going to take a look at DOM-based attacks, then injection and broken access control. Then we are going to have to extract those features from our request and responses. So we are going to take a look at the length, parameters, count, encoding patterns, frequency of special characters, and so on. And then we're going to train the model, evaluate it, and finally create our AI detection system. The tools we're going to use for this tutorial is, as I mentioned before, we're going to focus on OWASP Juicy Shop. Then we're going to need Pandas, NumPy, Python, Scikit-learn. We are going to run our experiments on Google Lab. We need the Burp Suite to intercept the request that we are going to send, and for Swigger just to get some payloads from there. If we take a look at the threat model overview, we are going to be performing two different tasks. The first one, we are going to act as penetration testers or attackers. Then we are going to turn on the blue team, and we are going to create our system to detect malicious attacks. So the assets that we have, the web application itself, OWASP Juice Shop, the information that it holds, username, password, tokens, etc. Then we have the ML detection model and the requests that we're going to use. And for threat actors, the attackers, we are going to perform different attacks using payloads, obfuscations, and different techniques to evade detections. And trust vendors, we have the internet, the web application, detection system, and login and alerting. So let's get started. I'm going to be using Kali Linux for this. However, you don't really need Kali if you only need the tools that I mentioned previously. So the first thing that we're going to do, we're going to visit OWASP Juice Shop because we are going to install it. If you want a full and complete description of how to install it, just let me know in the comments, and I'm going to share on my GitHub repository the steps to successfully install OWASP. As mentioned before, it says that it's modern, sophisticated, insecure web application. It can be used in security trainings, warning demos, CTFs, and as a guinea pig for security tools. So here on the right side, we are going to click on installation. As you can see here, I'm going to be using Docker image. Why a Docker image? It's much better, it's faster. The cons is that you are not going to get access to all the challenges, but you still can practice and develop projects with this. So now that we are here, we're going to scroll down. As you can see here, we have the table of content, the setup. If you want to install it from the source, here you have the comments, the package, and Docker container. This is what I'm going to be using. First of all, we have to install Docker. One more time, if you want me to share the full setup step by step, just let me know in the comments. Then we are going to pull the image and run that image, which is something that I already did. As you can see here, I am already running. Here you can see it says server listening on port 3000. So let's go and visit port 3000. So we're gonna use that later. So we go localhost port 3000. And there we go. Here is the application. I was already testing our scripts. So let me refresh the cookies one more time. Otherwise, it's not going to give us the full output. Let's remove here. Okay, just let me close. Let me restart one more time. If this is your first time, you are not gonna have to deal with all of this. I was just testing our project. So now let's go back to localhost 3000. Oops, it seems that it's still loading. Oh, there we go. So here is the page. So we are welcome this with this message. We can dismiss right now. Let me explain real quick about the website. So it's a kind of an e-commerce website where you can place orders. However, there is not a checkout process at all, but you can place products, you can leave comments, leave likes, interact with the website. You can actually create an account. You can log in, create an account. They have a forgot your password option. Here they have the menu. So if you want, you can explore these links one by one. So we are going to focus on our project. So the first thing that I want to do is whenever I have a web application, I like to test always login forms, register forms, and see if they have some kind of vulnerability. So usually, first of all, let's start Burp Suite. Then we're going to turn on Foxy Proxy for Burp Suite. And here I am going to send normal data just to see how the application works. I want to understand how it behaves. So test.com password, simple as that. So the first thing that I noticed is that it doesn't tell you anything about the minimum or maximum length of characters for the password. So let's try to leave it as 1, 2, 3, 4. Let's see, it's on, everything is on. Yes. So let's click on login. Oh, we got invalid email or password. Let's check our request on Burp Suite. So here we can see our post request. Let's send this to repeater. So here we can see our parameters, email and password 1234. Let's send one more time the request, and here we got the response invalid email or password, which is the same that we have here. So the next thing that I like to do is try simple payloads for SQL injection in this case. So the first one that we are going to try is a single quote in the email field, and then we're going to send the request one more time. Oh, look at this. So it seems that we got an error message, specifically SQLite error, which means that this website is vulnerable for SQLite injection. So if we take a look at the page, we can actually see that we successfully solved a challenge. Error handling provoked an error that is neither very graceful nor consistently handled. So let's test it out here, just single quote, and then let's see the output. Object. This is the error handling that we got. So then we can go back to our dashboard. Let me set and click on the target. Let me go localhost, reset here, user. So here is our form, this one, the reset user login. Just I am going to send this post request to intruder. So the next thing that we are going to do in this example is we're going to try different payloads and see how the website responds to this. So here in our email, the first thing we're going to do, we are going to click F. Then we are going to go to passwords as well if you want, and F. Then on the right side here, we are going to add some payloads. Here we're gonna leave it at simplest. Let's do it only with the email field, since here it was where we detected the vulnerability. So here we have, yes. Let's add our more payloads, like or true. Looks true. Let's do admin or 1 equal 1. Let's do double quotes. One more time, single quotes, and so on. So what we are going to do here is we are going to automate our process instead of testing here on this input field one by one. Like, okay, let's see if it's vulnerable to this one. Oh no, it's not. That one doesn't work. Let's use double quotes, and let's say login again. Oh, it seems that it's not working. Invalid email or password. So what we are going to do here, sorry about that, it's we're going to automate the process and send automatically different requests with different payloads. So you can see here, we don't want to URL encode these characters, or for this example, let's see what we get. So start attack. Now Burp Suite just opened a new window, and here we can see that this payload successfully worked here, as you can see, and we actually were able to log in because it seems that we have some kind of token. So here is our initial payload, and here we got the error. As you can see, all these attempts seems that they worked else because we got the error. So when we want to try different payloads and see, hey, maybe the attacker doesn't know this payload, or maybe there is a payload that I don't know. So let's try to create the model and test different payloads, automate this. So that's what we are going to do later. But first, let's go back to our vulnerable website. So if we try the payload that we just saw, that it was admin, I think it was this one, or true dash dash, and we click enter. Yes, we can see that we successfully solved the challenge. Log in as admin. So here we can see we successfully log in as admin. This is pretty bad. It's a broken access control issue. Now let's go back to our form one more time. Let's go to login. So we have discovered Scikit-learn injection that allows the attacker to log in as the admin with an administrator account. Now let's try to see if we can log in with a different account. Let's see if there are any names or information here that we can use. Let's go to reviews. Here we see an email, and we're going to copy that. We're going to go to account, log in one more time. Here, what we are going to do is we're going to try to log in with a different user. We don't know this user's password. However, we're going to try to bypass that. So we're going to have the user email, single quote, and then dash dash. And then we're going to have whatever we want here. And enter. As we can see, we successfully log in as vendor. We see here, there we go. Let's go back to Burp Suite. Let's see our request. Let's go, let me see, is this one? No, post request, this one. This is the one that we tried previously. Let me see here, set. Oops, no. It's not the one that we're looking for. Email password here one. This is the one that we're looking for, vendor. And we send this to repeater one more time and send. We can see that we were able to log in. Now, if we want to do the same process as we did previously with the Scikit-learn injection, we can send this to intruder. And then we can add here this position. And then here we can start trying different names. Let's say John, let's say admin. Let's see if there is any other name here that we can find. Reviews. Oh, 2 reviews. It's 10. As you can see here, once you log in, now you can add comments. It should be great if you test this input field here to see if there is any kind of vulnerability. But now we are just looking for another name as Stan. Let's go as and let's test this. So let's start attack. Okay. Now we can see that all our payloads worked. We were able to log in as John. Then we were able to log in as admin. So you can see here admin, Stan, and here we were also able to log in as Stan. So most likely this website is vulnerable to all users will be vulnerable to this kind of attack. So let's go back here, and now let's log out one more time. Then click on forget password. Something that I also like to do is, okay, we found some usernames like vendor, like scam. We don't know their password. Let's assume we weren't able to access their accounts via the SQLi injection. Now we want to retrieve the password. Let's say we want a Gym password. We want to recall. We forgot the password, so we're gonna do gym at choose sh.op, and here we have a security question that it says your eldest sibling middle name. So at this point, we do not have any kind of information about our target user. So what we usually do in this step, it's what it's called open source intelligence. We're gonna try to look for information on available open sources without nearly interacting with the target to gain as much information as possible. And here, for instance, we need a name, the eldest sibling's middle name, but sometimes people, they have their pet's name, their favorite team's name, or some kind of information that we can find online. So here for this example, we're gonna go to the first of all to the website and see if we can get some kind of information. Let's see if Jim has posted something. Maybe he has been interacting with the website. So I found out this post by Jim. It says fresh out of a replicator. Not sure what it means. So what I do, it's replicator. I googled that word, fresh out of a replicator. And it says replicator commonly refers to Star Trek technology. So we can infer that Jim is a Star Trek's fan. So let's keep digging in the website and see if we can find more information about the user. In here, I also found information that Jim was sharing. Looks space symbols, new trick quarter. I don't know what that is. So I come to trick quarter. Let's see the output, and it says that is fictional handheld sensor that exists in Star Trek's universe. I will never had idea about this because I am not a Star Trek fan. But here, now we can start assuming that Jim most likely will include some information from the Star Trek series in his password, maybe when he created an account and he was asked about his favorite movie, his favorite series, maybe, or other kind of information related to Star Trek or what he likes. Now we found this last post about Jim that says Starfleet, which is also related to Star Trek. So then I go back to the point that we have your oldest sibling's middle name. So Jim has been talking about Star Trek in different posts. So then what I do is Jim Star Trek eldest sibling, and let's see if we get something. So here we got that the oldest sibling's name is George Samuel Sam Kirk. So maybe one of these options will fit here. So let's see. George, new password, very safe password, new password. Let's click change. Oops, it's in, that's not is the correct answer. Let's try with Samuel this time. So sample new password, new password, new password. Let's click change. Oops, it seems that we were able to change Jim's password. Let's confirm that. We're gonna go to login, and here we also got this pop-up message that we were able to reset Jim's password. Let's see, Jim at juice.sh.op, and here new password. Let's log in. Yep, we successfully logged in as Jim. So now what we are gonna have to do next is we have to report about this vulnerability as well. But it's not only about a vulnerability that the question. That's why it's very important to have multi-factor authentications and include something that you know, like in this case, the other sibling's name, but you also have to include something that you have. For instance, your cell phone, you have your cell phone, you can send a message to that cell phone or to your email. And then something that you are. Here we can add some fingerprints or some kind of biometrics. That is how we are going to improve the security in our company, especially here in this form. As you saw, it only asks for a simple question. There is no multi-factor authentication or extra steps to change the password, so we have to notice that as well. So now we can let's see if we can register an account. So we click on not yet a customer. Something that I like to do is usually create fake emails and see whether the company takes their cybersecurity posture seriously. If they do, most likely they will say, we are going to contact you, confirm with this email. If not, it means that you can create a bunch of bank accounts, and then we have to struggle with it in their database, in their system. You can collapse their system just by creating thousands of accounts. So then let's create one. So test password, repeat password. Let's choose the security questions. Eldest. Let's use George. Yes, we're gonna use George. So we can click here, close this, answer, and register. So registration completed successfully. So now let's go back to Burp Suite. We don't need this anymore. Let's go to here, target, APIs. The one that we need, I think, is we need to create an account. It's going to be here. So where is it? Let me scroll down, reset. It's, where is it? Post. There we go. Nope, it's not this one. Oh, target, email, team, reset password, security question. This is the exercise that we already did. When we reset the password, so now we have to find registration. Let's see, user res, log. It's gotta be somewhere here. API users here. Yes, this one. Let's send it to repeater and send a request. We already created this account, so we got this email must be unique. So let's test it out with test number 2. Sorry, test 1, and then we click on send and see the response. So we successfully created a new account. But something that it's really dangerous, it's an information that shouldn't be included in the response, is these kind of things like a role, the type of account that you are creating, or that you the type of the account that you can get access to, because this means that you can have more permissions or privilege depending on the account type. So once we get this, we can try to create an account with a different role. So we copy that, and here let's see if we can create an admin account. Admin, let's use admin account, so they won't notice that this is an backend account. So choose search.op password, admin password, there it goes. Here's the question, George. Now let's click and see what we got. Oops, it seems it worked. We successfully created an administrator account. As we can see here, it says that status success is active, true, role admin. We created an administrator account, and here we can see that we got this message, and then registration, register a user with an administration privilege. As we can see, we also discovered what we mentioned, that we were able to create thousands of accounts because the website it's not doing any kind of validation. So now we can also do the same as we did before. We can send to intruder, and then we can change the parameters and automate our payloads and get the request and see how it works. And based on the response, let me see if I this one. Let me send this one more time. So now that we have successfully identified vulnerabilities, input fields that are not validating users' inputs, that we can create administrator's account, and that we were able to register multiple accounts, recovered some kind of, not recovered, sorry, reset the password. Now, what we usually do is, okay, we tested this payload. For instance, here we have reset user login authentication. So what we are trying to do here is abuse a SQL injection vulnerability and try to log in as a different user with an unknown password. Here we see John, and then we got this response number 200. We also get some information about the response type, the amount of data. So what we usually could do for the next step, which is future instruction to train our model, we could click here save, and then it's going to display the options to save it, all the responses as CSV file, but you need the Pro version, Burp Suite Pro, to download the file as a CSV. Since we don't have that, we will manually create that. So now the next step in our project is the project's web attack automation script. So here I have already created the script for you. I'm gonna take you through it. So the first thing that I do, we import some libraries, then here our URL, or base URL. Does not necessarily have to be the victim IP, but in case it is, this could be. But so first of all, base URL, some headers, then here dynamic loading payload from select list. Do you remember here in this step that where we were entering the payloads one by one? Here, one by one, we don't want to do that. We have already some lists that we can use from Kali Linux, or that are available on the website. You're gonna find thousands of files about different payloads for different vulnerabilities. But in this case, I'm going to load the files from these paths. So for instance, if you want, we can take a look at this, and 15. These are some of the payloads that we're going to be using. So here we have different paths, different files, and these are some manual hard-coded payloads in case the previous one don't work. The same for cross-site scripting. For broken access authentication. So here we follow the parameters that we saw in our request. But then we need the email, answer, a new password, repeat that new password. So we have to match the output in our response. For instance, here we got email, password, repeat, role, security question, and security answer. We also need to include those fields here in our code, otherwise it's not gonna work. So this we have for all different type of payloads. What we do, we test one by one. It's gonna go to the target IP, to the target URL. As you can see here, it's going to test for different kinds of URLs that we did manually, but this is going to be automatic. So I just noticed that I forget to show you cross-site scripting. So here, cross-site scripting, we have three different types. The first one, it's called reflected, which is when for instance, here I'm going to script alert, and one, if this search bar field would be vulnerable for a reflected cross-site scripting attack, it should display a pop-up window with the number one alert message. In this case, it's not working for that. But then we have another case, which is the store cross-site scripting. Let me log in so that we can see how it could work. So here we have, let's say, a basket. Oh, sorry, we click on here, we can write a review. So here is where we are going to inject our payload, but the difference is that this is not going to be displayed immediately, but it's going to be stored in the system. So the next time a user visits this website, it will display the message. So if we send right now, we can see that it does not display the pop-up window with our alert message. And if we visit again, it's not going to show any kind of attack. But if this this field were vulnerable to store cross-site scripting, we'll see it. And now we have the last type of cross-site scripting attack. Just let me close all of these. So now we can test with different HTML elements. So the first thing that I did, H1, and let's see, oops, let's try something like hello. Oops, we can see that it's displaying our input here in this field. Now let's try to see if we can do something different. Maybe we can add a different value. Let's just display this. Yeah, it's working like that. One more time, let's do our example with H1. Now let's try book. See, yeah, let's right click, inspect. What we want to see right now is where this element is being displayed within the body of the web application. So here we can see that it's creating this element within this HTML, but it's dynamically being created. So let's see if we can try to create or add a new element, a new object to the website. So we can try to use iframe, for instance, then source, double quote, JavaScript, semicolon, alert, brackets, then DOM, cross-site scripting. Don't forget to close our iframe tag. And let's see if this will work. As we can see, it worked. It displays our dump XSS message. And we can see actually in the background that it's actually trying to create an iframe element within the DOM structure of the website. So here we can also do the same and change this payload and try different one. So now I am going to reset everything and test the automated script, which is going to be available on my GitHub repository in case you want to try it, modify it, or maybe you think it's useful. Let's go here. Let's stop, reset. Let's rerun this one more time. Okay. Let's see. It's not working yet. Let's give it a few seconds. Server listening. Okay, it's working now. Let's delete cookies one more time. Oops, let's see. It seems we didn't delete the cookies, so we are going to do that right now. Let's close this one more time. Sorry, let's reset. Okay, it seems that it's working. Localhost one more time. Now we can see again the website with no cookies. Now it's time to test our script. Let's take a look at it one more time about what we are doing here. Let's remember. So first of all, what we are going to do is, hey, visit this website first of all. Then we are going to have here a bunch of payloads from these paths. We are going to load and test those payloads in different fields for broken access authentication, broken access control, mishandling exception, and so on. So we are going to test the payloads depending on the URL, the target URL. So what we already did, that is, it's automatically. Now let's run and see if it works. So run web attack dataset collection tool. First of all, it's going to prompt that if you're running already, use the shop. In this case, yes, and then we click enter. As we can see, it started loading different payloads, and here in the background, we can get that some of those payloads are already working. We don't know how many yet, but we see that they work some of them. So we were able to log in as an administrator, but broken access control, security misconfiguration, broken authentication, and here we can have error handling. And it seems that we are just testing right now SQLi injection. It seems 19 out of 354, no, 22 out of 354 worked. Now we are getting more responses, more attacks are working, are coming. This is not stopping. Imagine that these were a real environment in a real company, and someone is actually running this script, creating a bunch of accounts, getting access to administrators account, to all kind of users account. This would be pretty bad, and it's just taking a few seconds to run this script to understand how it works and all the steps that we previously did. It takes a few time, but this is much faster than anything. And nowadays, you know, with AI tools that we can, with a simple prompt, create very dangerous tools that could allow bad actors attack your company and harm your systems. So this is why we are creating this project, so we can show how easy is not only to attack but also to protect. So now that we got the results, we see that we tested normal payloads, SQLi, cross-site description, broken authentication, and input validation. Let's take a look. Just a few lines of our results. So here we have payload attack, payload attack type, the status code, response length, time, success, error, the information that we found on Burp Suite. Okay. So once we have generated this web attack result, CSV, this one, the next step is to extract those features. As you can see, we have quotes, we have strings, we have numbers, we have brackets, we have semicolons, different characters. For a token also, we have some encoded characters. So what we are going to do right now is we have to extract those features, because machines don't understand words, just numbers. So what we are going to do, we're going to extract those features, then we are going to convert those strings into numbers, and then we're going to train the model. So let's go here. I already have this opened. Let's reconnect. Oh, it seems that I will sign out. Let's sign in. Okay, so now let's go back to the top of this. Don't get scared. So features extraction. Here's our code. So first of all, we're gonna use Pandas and some libraries. Oh, it seems it worked. Yes. how we are doing this extraction process. So first of all, basic characteristics that every single request and response has. The length, digit count, alpha count, special count, and special count. This is very important because it's how we are going to identify possible attacks based on different kind of patterns or indicators. So the first thing that we do, we specify how we are going to identify those possible attacks, possible payloads. So we extract them, we convert them to numbers. So let me do it everything one more time. Just let me delete this so you can clearly see the output. Let me delete all these files. Okay. Now let's upload our web attacks. The file that we just got from the previous output from here, this one, we're going to upload that file. Then once you have successfully uploaded the file, we are going to copy the future extraction code, and then we're going to paste it here. Then we're going to click run. And we're going to scroll down and see the output. So here we have 1,301 samples that we are going to work with these 39 features. So here, when it comes to machine learning, we have features and labels. In the case of features and label, it's how we are going to identify and classify our data. So we are going to have the features, in this case, the user's input, and the label, the attack type. Okay. So then we move on to training our model. First of all, extract the features that we need. We don't want to see these correspond, we don't want this authentication, we don't want this token information, these numbers right here. We don't want that. So we extract the output. So for instance, here we have status 200. We need that information. We need the payload as well. Yes, of course we need the payload. What kind of attack was performed? SQL attack. That's the information that we need. The length, response time, but we don't need these brackets, we don't need the encoded characters. Now let's train the model. In the training part, first of all, we prepare, as you can see, once we run the feature extraction, it generates these ML dataset features. In train model, you're going to copy the code from the train model.ty, and here we just basically prepare the first part, the features and label, what I mentioned, the features input, users input, and labels attack type. We evaluate the model, we balance. Here I'm using a random forest classifier. I consider that it's better when it comes to text or strings. We are training 80% of the data, and 20% is being used for testing. Then it's going to create these files you can see here. Let's see the output. Model training, 1,040 training samples, test samples 261, and features 39. Accuracy 0.9847, which means that our model, we have two options or two interpretations in this case. Our model is pretty good at detecting or learning patterns, or it's pretty bad that the model just memorize every single pattern instead of learning, just repeats and see oh, maybe this is what I saw previously and it's not learning. Um, why this could be the cause of the error? The main reason is our dataset. We are using a small number of payloads, as you can see, less than 2000. So it's not enough information. And the model will take some similarities in the patterns and will interpret as if they were the same kind of attack. So once we have created a model training, that's why if you want to improve the model, it's better to have a larger data set. We have also k-validation we are including here as well, but we can also work with some different batches or chunks when we are working with a larger data set. Now let's go to the AI detector. Now that we already generated, extracted our features, and then we train our model, and then we created the files that we need, it's time to detect the attacks. So here, as you can see, we have to use the same features that we find in the feature extractions. If this does not match, it's not gonna work. You're gonna get an error. So here, first of all, we detect the attack type, recognizes pattern, and then creates a response based on that. So if we test it out, we can run. As you can see here, it says that we can enter a payload to analyze. So let's go with single quote. As we can see, the prediction says that it's most likely SQLite injection 98.9%, which is pretty accurate actually. But in our model, let's use tests. It will automatically run different type of payloads for us and see how it behaves. So let's go to the first one I see. Where is it? Right here. Here, test. So the first input is a SQLite injection and successfully detected. It says 99.6%, which is pretty accurate. Then the second input was the script alert. It also successfully identified as cross-site scripting. Then it seems that we are trying to create to reset someone's password, as we can see here, symbol, if you remember from the video. Broken authentication, 69%. It's pretty good because this could also be interpreted as if someone were trying to register an account. So for our difference here, we got expected broken authentication and we got broken authentication. Then the same for this one. So it seems that we're trying to create a new user with admin privileges. It detected input validation. As we can see, someone was trying to change that. Hello world, normal, perfectly detected. So we can see that it's all working. So thank you very much for watching this video. If you like, just leave a comment, leave a like, and let me know if you want to get more information. All the scripts, all the code will be available on my GitHub repository. Call me Kali with triple I in the end. Thank you for watching.